Okay, so when we're dealing with multi-loop circuits, we'll have a couple of rules, and we've already seen these already. These rules are called Kirchoffs rules. The first rule is the junction rule, which, as I said, we've already seen. It just says that the sum of the currents entering a junction must equal the sum leaving the junction. This is due to the conservation of charge, conservation of energy. You can't just create charges. So, so the junction rule. And so, for example, if I have a current I coming into the junction, I have currents I1 and I2 leaving the junction. And the junction rule just says simply that I is equal to I1 plus I2 plus however many places we have leaving out. So simply that IN equals I out. We've already used this in parallel circuits. It's a pretty handy rule, but we'll find it's useful also in multi-loop circuits, which is a type of parallel circuit. Right? The loop rule, which we've also used, but it just says that the sum of the potential differences across all the elements around any closed loop must be equal to 0. Right? The sum of the voltages across a loop must equal 0. Again, we've already used this before, right? Where if we said that we have a battery of 12 volts, if we have 7 volts here, for example, then we have to have 5 volts here. Simply what the loop rule is saying, that 12 minus 7 minus 5 equals 0. That's a true statement. So we've been using the loop rule all along. And so in equation form, it would just say that V, or rather the sum of the voltages across the loop, is equal to V plus V1 plus V2 is equal to 0. Now in this case, depending on how we look at it, but we'll find that V1 and V2 are equal to 0. We'll have some separate rules describing that because they can be either positive or negative. We'll see that in just a bit. All right. Now, we'll have a few guidelines, and we will come back to these.